Hello everyone, and welcome to the introduction to research methods in psychology. Second module. Before we start, I would like to speak about reading quizzes. Some of you who have good attention to detail noticed that I didn't put a deadline on the first quiz. That's no accident. There are two reasons for that. First, there are some students who start a little bit later. I don't want to put them in a disadvantage. And second, the sole purpose of reading quizzes is to prepare you for the midterm and for the final exam. I completely understand that sometimes life happens, and you have no possibility to go through a reading quiz in 1 week. If I put a deadline to the reading quiz, you will lose the possibility to prepare yourself for the midterm. So, I decided to allow you to be flexible, meaning you can decide for yourself if you want to study each week a bit, or if you want to go through all the assignments at the very end. If you don't like this decision of mine, please write me an email and I will put a usual deadline to the reading quizzes. I am also not a snitch. I will never tell you fellow students that it was you who wanted to have deadlines. Okay, let's continue with the material of our course. In this lecture, I will highlight everything that I find more interesting or more important from the chapter 2. What is the difference between theory and hypothesis? Well, both a theory and hypothesis and explanations. Well, theories are explanations that go beyond the data. Theories are broader in scope than hypotheses and can and usually incorporate multiple hypotheses. They can also try to explain unobservables. Famous examples of theories will be a Big Bang theory or an evolution theory. Hypotheses are more prediction than an explanation. A good scientific hypothesis always have the structures of if and then. An example will be a hypothesis about the Big Bang theory. If this theory is correct, then the universe will continue expanding. A hypothesis can compare two theories. Well, let's find an example from psychology. A good hypothesis can be to compare two theories, a behaviorism and a social learning theory. To compare these two theoretic approaches, we can think about conducting an experiment where two groups of children will watch a video of an adult being aggressive towards a doll. After that, one group will receive a reinforcement for mimicking this behavior, and another group don't. If we can compare levels of aggressiveness in these two groups, we can conclude which theory explains this phenomena the best. If that a behaviorism, then the group that received a reinforcement should show a higher level of aggressive behavior. Because according to behaviorism, a behavior will learn if it gets somehow reinforced. If there is no difference between two groups, then a social learning theory may explain this phenomena of aggressiveness in children better. According to social learning theory, the observation alone, without any direct reinforcement, can lead to learning and imitation of behavior. Both a theory and a hypothesis is a part of a model of scientific research. You can find a very nice graph in your textbook that represents a model of scientific research in the form of a circle. I also find a funny comics if you prefer an informal approach more. Each and every research is started with a research question. A research question is usually rooted in informal observation or any practical problems. After we formulate our research question, we usually start with a review of research literature. By research literature, I mean research articles that you can easily find through Google Scholar. Or, if you prefer it more, you can use a PubMed or any other similar research portal. Usually, after a systematic review of research articles, we have to change our research question. Maybe there is exactly the same study we thought about, and this research question is already answered. Or maybe you lost your interest in this research question and would like to try something else. Usually, you have to change your research question a couple of times, and even after that, you have to refine it. The final stage of the refining of your research question will be a formulating of a research hypothesis. After that, you can start with your empirical study. At first, you should plan how many participants you would like to test, what methods you would like to use, and what procedure you will find the best for your research question. Planning an empirical study is my favorite part of each research cycle. My least favorite part of each research cycle is a part when you test your participants. This is because I work with infants, and as cute and as sweet as they are very tough participants. When you got all the data you need, you shall start with statistical analysis of your data. You will learn has your hypothesis confirmed or not. Never have I ever got the result from my study as similar to the results I anticipated. And this is an experience many researchers share. Based on the result of your data analysis, you can form a conclusion. If you're listening to me and looking at the comments, I would like to point a mistake in it. The result should be posted not only when they are exactly as expected, or at least more or less as expected. They should be published even when they are not at all as expected. Otherwise, you will get a publication bias. A short memo about the relationships between theories and hypotheses. There are two ways of use a theory by interpretation of our results. The first way is when we use a theory by explaining our results. But there is a second way, when we form our hypothesis based on a theory, and then we test our theory with our research. We can then re-evaluate an existing theory or maybe decline this theory and invent a newer one. Now, when we spoke about the whole research cycle, let's speak about its part in a detail. What makes a research question a good one? In a textbook, they just use two big criteria: F, feasible, and I, interesting. Those two criteria are from the FINER model. A good research question is a feasible one. It should not be feasible for a research as a whole, but for a concrete researcher. As sad as it is, not each researcher has the same possibilities. Some universities and research centers have more advanced methods to use, for example, an MRI scanner. Another obstacle to think about is the time. Sometimes you need to create a research in a very short period of time, when we speak, for example, an honors thesis. Another criteria for a good research question is to be interesting. A research question should not be just interesting for you, but that helps a lot to stay motivated. But it also should be interesting for another researcher. Otherwise, it will be much harder to publish your work and also to find any reaction in the research society. A good research question should also be novel. It doesn't mean that nobody have ever thought about this phenomenon. Usually it means that a phenomenon you would like to research is well studied, with exception of some specific thing, and this thing is your research question. A good research question should also be ethical. It is worth to mention that our understanding of what ethical or not changes with the time. A lot of classical psychology research that was conducted many years ago will not be possible to conduct nowadays. And the very last, but not least, your research question should be relevant. It should not be relevant for just another researchers, but also for a society. A good hypothesis has very similar criteria. A good hypothesis should be testable. Being testable is an essential criteria for a good hypothesis. Another criteria for a good hypothesis is be falsifiable, meaning a hypothesis can be proven wrong. A good hypothesis should also be logical, so not just be a random guess, as much as funny as it can be. A good hypothesis should also be positive. We, as scientists, try to prove if something, for example, a specific phenomenon, is existing, and not that something is not existing. Part of the hypothesis generation is defining the variables you would like to study. A variable is something that varies across the people. Variable can be quantitative or categorical. An example of a quantitative variable is height in centimeter or IQ score. An example of a categorical variable is something that cannot be put on a scale. For example, is a chosen major. After we defined our variables, it is time to define them in a sense of how they can be measured. This process is called operational definition. Some variables are pretty easy to measure. For example, if we want to measure height, then we can measure it in centimeters or in inches. And other variables are impossible to measure directly. For example, an intelligence. In this case, we can define an intelligence as an IQ score and measure it with some IQ test, or if we want so, we can define intelligence as student success in study. Next step will be to define a population for our study. For example, as a developmental psychologist, my population usually is all the infants in the world. Of course, it's impossible to test all the infants, and this is why I have to choose a sample. Sample is a small group that represents the population. There are many methods of obtaining a sample. For example, there are about 12,000 infants being born in Edmonton each year. Let's say I will need to test 1% of all these infants. I can send an invitation for every 100 family in a hope that they will participate. That sounds as a very nice method, but in reality, at least in case of infant studies, it does not work at all. Usually, psychologists choose a convenient sample, meaning that in my case, if I want to test 100 infants, I will send invitation to all the families and just test all of them who will willing to participate. A big disadvantage of a convenient sampling is that a sample that a researcher will choose will not represent the population. In infant studies, it is usually so. Our participants came from middle class up to upper middle class. They are usually from ethnical majority of the countries that being tested. They are also healthy. They are also provided with more resources than a usual kid will be. After the researcher decided what they want to test, they should decide how they want to test. Let's say that we would like to research how does the amount of time you spend studying affects your grade. We can make our research experimental. We can choose independent and dependent variables, time you spend studying and your grade. We can also choose what variables we would like to control. For example, the time of the day when you are studying, or the amount of food and drinks when you're studying, or maybe the size of the textbook, or maybe the grade you were starting with. How does that affect your final grade? A hypothetical study here will be that we will recruit, we'll say, 90 students. 1/3 of them will study 1 hour a day, another 30 of them will study 2 hours a day, and a third group will study 3 hours a day. We can also try to recruit a separate control group who will not study at all. Another possibility is to make our research a non-experimental. We can still recruit 100 students, but we will not put them in different groups. We will just ask them to record how much time they spend studying. We can still control all the variables we would like to control. We should just ask students did they eat something, or when they were studying. Next major distinction between types of the research are laboratory settings or field settings. None of these settings are perfect and none of them are bad. By choosing between laboratory settings and field settings, there is always some trade-off in validity. When we test in laboratory, we have more control on all the variables. This means we have high internal validity, but also a low external validity. There are, of course, some research questions that are impossible to test in the field, or there are, of course, some research questions that you cannot test in the lab. Let's say we completed our study in the meaning that we tested all our subjects. Now we can start with something that almost all the students really don't like, with analysis of the data. There are two types of statistics we will use. We will start with a descriptive statistic. A descriptive statistic is being used to summarize a set of data. An example of descriptive statistic can be mean, median or mode, range, standard deviation, variance, and correlations coefficients. This is not a stats class, so I will not spend a lot of time speaking about statistics. Using an inferential statistic allows researchers to draw conclusions from their data. Researchers use inferential statistics to determine whether the effects are statistically significant. In psychology, a statistically significant effect has less than 5% chance of being due to random error. Again, statistics are probabilistic in nature. Using a statistic allows researchers to determine whether the chances are low that the results are due to some random error, but they will never have any absolute certainty in that. Speaking about random error, there are two types of errors, type 1 and type 2. I found a pretty funny picture that you can use, and I hope that it will help you to memorize which type of error is which. Type 1 error is false positive. This is when a researcher concludes that their results are statistically significant, meaning there is an effect in the general population. In the reality, there are no such effects in the general population, and the results are just being due to a chance. In a case of a type 2 error, everything is other way around. A researcher concludes that the effect is not statistically significant, meaning there is no such effect in a general population. But in the reality, there is. A usual reason for getting type 2 error is setting a sample way too small. Circling back about theories. Theories cannot be proven or disproven based on the results. Theories can be supported or modified based on the results. Why? Because our results are still probabilistic, meaning that we are prone to type 1 and type 2 errors. There can be another theory that will do exactly the same prediction, which is pretty common in psychology. There will be future studies, and they can confirm or disconfirm the theory. And even in our study, there can be a problem with the study results. Okay, thank you. That will be all for today. Take care and goodbye.